Hi all. In this video we're going to discuss another method of random sampling called stratified sampling. In stratified sampling, what we do is we take our population and we sort our population based on some characteristic of interest. Not population, population. Don't judge me. And we are sorting our population into groups based on that characteristic, and we call those groups strata. So this could be, if I'm a high school teacher, grade level. This could be by age groups, right? This could be by gender. This could be by state of birth, right? Were you born in California or New Mexico? It could be by any socioeconomic strata that we want to sort, whatever variable of interest, right? We know in medicine often that age and gender are often big comparisons because we want to know whether the medication works the same for young people as it does for old people. Does it work the same in testosterone-driven bodies as it does in estrogen-driven bodies? So we're sorting ahead of time based on some characteristic of interest. Once I have my population sorted into strata, into groups, I am then going to take a simple random sample from every group. I'm going to do an example because there are two sampling methods that involve grouping and they get confused fairly frequently. So I want to make sure we've got a visual in our head for this. So I am a statistician and I want to collect the opinion of high school students at my high school, Rancho San Juan High School, on the new schedule that we're planning on implementing next year. Yeah? So I need opinions from high schoolers on new schedule. And I want to make sure that my opinion represents the entire Rancho San Juan student body. And we know that students in high school range from new freshmen who are 13, early 14, all the way up to graduating seniors who are 18, 19. And kids who are 13, 14 are very different from students who are 18 and 19. A lot of maturity happens in high school. How do I make sure that my population is represented in the sample? And stratified sampling is ideal here. So what I'm going to do is I am going to take my Rancho San Juan students, and this is all of them, this is the whole school, and I am going to sort them by grade level. So all RSJ freshies, all RSJ sophomores, all RSJ juniors, and all RSJ seniors. Sorting them into strata like that make sure that I'm going to have a couple kids from each age group in my sample. And that's important because I know freshmen are going to view scheduling different than juniors and seniors that may have licenses and cars. From each of these grade levels, I am then going to select a simple random sample of 25 freshies. And then I'm going to do the same thing for each age group. So simple random sample of 25 sophomores. Simple random sample of 25 juniors. Simple random sample of 25 seniors. And what I end up with at the end of this is I end up with a sample of 100 high school students. But this sample of 100 RSJ students represents that population in terms of grade level more accurately than a simple random sample from all students in the school. So if I do a simple random sample at the beginning from this group here, I could end up with a sample that has a whole bunch of freshmen and no seniors because of random chance. I could end up with a sample that's a whole bunch of sophomores and juniors, hardly any freshmen and seniors. So when it is important that my final sample provides an accurate representation of the breakdown of groups in my population, I want to use a stratified sample. I want to separate them based on some category before I do my SRS. And I do my SRS from each group so that each group shows up in my sample. All right, if you have any questions on what a stratified sample looks like or why we use them, feel free to send me an email. Otherwise, I will see you in our next video on cluster sampling.